in road construction is planning and surveying the site. Engineers study the geography, soil types, and traffic patterns of the area to determine the best route and design for the road. Advanced tools like GIS, Geographic Information Systems, and GPS are often used to map the terrain accurately. Surveys also identify potential obstacles like rivers, hills, or existing infrastructure that may influence the route alignment. This stage is crucial for ensuring the road's feasibility and long-term functionality. 2. Design and alignment. Once the planning phase is complete, engineers move on to designing the road. This includes deciding the road's alignment, width, gradient, and cross-section. Proper alignment minimizes sharp curves and steep slopes, enhancing safety and driving comfort. Engineers also design drainage systems to prevent waterlogging and extend the road's lifespan. Computer-aided design (CAD) software is often used to create detailed blueprints and simulations of the proposed road layout. 3. Clearing and excavation. Before construction begins, the site is cleared of any vegetation, rocks, and other obstructions. Excavation work follows, where earth-moving equipment like bulldozers and excavators are used to remove excess soil and shape the terrain according to the design. If the soil at the site is unsuitable for supporting the road, it may be replaced or treated to improve its strength and stability. This step prepares a solid foundation for the subsequent layers of the road. 4. Subgrade preparation. The subgrade forms the base of the road and plays a critical role in its overall stability. The soil is compacted to achieve the desired density and strength, ensuring it can bear the weight of the traffic and road structure. Sometimes, geotextiles or other reinforcement materials are used to enhance the subgrade's performance. Proper subgrade preparation is essential for preventing road failures like potholes or cracks. 5. Base layer construction. Above the subgrade, a base layer of crushed stone or gravel is laid to distribute the loads from the road's surface. This layer provides structural support and helps with drainage by preventing water from seeping into the subgrade. The base layer is compacted using rollers to achieve a uniform and stable surface. In multi-layered road construction, an additional sub-base layer may be added beneath the base layer for extra strength. 6. Paving the surface. The surface layer, which we commonly refer to as the road, is laid on top of the base. This layer can be made of asphalt, concrete, or other materials, depending on the road's intended use and budget. Asphalt is typically mixed at a high temperature and spread evenly over the base layer using paving machines. Once laid, the surface is compacted to achieve a smooth and durable finish. For concrete roads, the material is poured, leveled, and allowed to cure for several days. 7. Markings and finishing touches. After paving, the road is marked with lines and symbols to guide traffic. This includes lane dividers, pedestrian crossings, and directional arrows. Reflective paints or thermoplastic materials are used to ensure visibility at night. Additional features like guardrails, signboards, and lighting are installed to enhance safety and usability. Also be done to improve aesthetics and control erosion. 8. Quality control and maintenance. The final step involves thorough quality checks to ensure the road meets safety and durability standards. Engineers test the pavement's thickness, compaction, and efficiencies. Regular maintenance, such as patching potholes, resealing cracks, and cleaning drainage systems, is also planned to extend the road's lifespan and keep it in optimal condition. Conclusion. Building roads for the future. Complex and collaborative effort that combines engineering expertise, advanced technology, and meticulous planning. From surveying and designing to paving and maintenance, each step is. As we continue to innovate in materials and techniques, the roads of the future will be even more sustainable and resilient. Thank you for joining us on this journey through the steps involved in road construction. If you enjoyed this video, give it a thumbs up and share it with others who love learning about it. Subscribe to Blueprint to Reality and hit the notification bell so you're always updated on our latest. Keep exploring the fascinating world of engineering. The difference between highways and expressways. Welcome to Blueprint to Reality, where we simplify infrastructure design. Today, we're diving into the difference between highways and expressways, two essential road types that shape transportation networks worldwide. Though often used interchangeably, highways and expressways have distinct design features, speed regulations, and access controls. Let's explore what sets them apart. Definition and basic purpose. Both highways and expressways serve as major roads for vehicle transportation, but their purpose and design philosophy differ. Highway, a general term for any major road that connects cities, towns, and rural areas. Highways can have intersections, traffic signals, and varying speed limits. They may be two-lane or multi-lane and accommodate mixed traffic, including pedestrians and bicycles in some cases. Expressway, a controlled access road designed for high-speed travel with minimal interruptions. Expressways have limited entry and exit points, no traffic signals, and separate lanes for opposing traffic to ensure smooth vehicle flow. While all expressways are highways, not always qualify as expressways due to differences in design and access control. Road design and lane configuration. The design of highways and expressways varies based on traffic volume, safety concerns, and intended travel speed. Highways can be single-lane or multi-lane and may include intersections, roundabouts, and pedestrian crossings. Some highways pass through urban areas, meaning lower speed and more frequent stops. Expressways are designed for fast, uninterrupted travel with multiple lanes, usually 4 or more, separations or barriers to prevent head-on collisions. The design minimizes sharp curves and inclines to accommodate high-speed movement. Expressways prioritize efficiency and safety, making them ideal for long-distance travel and high-traffic corridors. Access control and entry points. A key distinction between highways and expressways lies in access control, how vehicles enter and exit the roadway. Highways may have multiple access points, including driveways, intersections, and local roads connecting directly to them. This can lead to traffic congestion, especially in urban areas. Expressways feature limited access points with control and off-ramps. Vehicles cannot directly enter from side roads or properties, reducing traffic conflicts and improving safety. This access control makes expressways faster and safer, but also means drivers must plan exits in advance. Speed limits and traffic flow. Since expressways are designed for high-speed travel, their speed limits are generally higher than highways. Highways have varying speed limits depending on location and traffic conditions. In urban areas, speeds may range from 50 to 80 kilometers per hour, 30 to 50 miles per hour, while rural highways allow speeds up to 100 kilometers per hour, 62 miles per hour. Expressways maintain consistently higher speeds, typically 90 to 130 kilometers per hour, 55 to 80 miles per hour, depending on country regulations. The lack of traffic signals and intersections allows for smooth, uninterrupted movement. Express travel time significantly compared to highways, making them ideal for long-distance and intercity travel and traffic control. Another major difference is how traffic is managed at road crossings. Highways often have intersections, roundabouts, or even traffic lights at various points. Some highways feature flyovers or undersea junctions to improve traffic flow, but many still require vehicles to stop or slow down. Expressways eliminate traditional intersections, relying instead on grade-separated interchanges such as overpasses, underpasses, and cloverleaf junctions. This ensures continuous traffic flow without stop-and-go delays. This difference enhances safety and efficiency on expressways compared to conventional highways. Toll systems and maintenance. Both highways and expressways require significant investment in construction and maintenance, but funding methods can differ. Highways are typically government-funded, although some major highways may have toll sections. Maintenance depends on public funds, which can lead to varying road quality. Expressways are often toll roads, meaning users pay fees to maintain the infrastructure. Many expressways use electronic toll collection (ETC) systems to minimize delays. Toll expressways generally have better road conditions due to dedicated funding for upkeep and upgrades. Safety and because it's better access control and fewer they tend highways. Highways experience higher accident rates due to intersections, mixed traffic, and pedestrian crossings. Sudden stops and unpredictable vehicle movements increase collision risks. Expressways have significantly lower accident rates since they eliminate conflicts from oncoming traffic, pedestrians, and cross traffic. Vehicles move at uniform speeds, reducing the likelihood of crashes. However, accidents on expressways can be more severe due to higher speeds. This is why expressways incorporate barriers, rumble strips, and emergency lanes to enhance safety. Highways and express. To better understand the difference, let's look at real-world examples. Highways. US Route 66, USA. A historic highway with multiple intersections and access points. Golden Quadrilateral, India. A network of national highways connecting. A6 Highway, UK. A major road connecting urban and rural areas. Expressways. Interstate 95, USA. A high-speed, limited-access expressway along the East Coast. Yamuna Expressway, India. A toll expressway with controlled access and high-speed travel. Autobahn, Germany. A world-famous expressway known for its sections with no speed limit. Conclusion. Highways and expressways are both essential to modern transportation, but they serve different roles. Highways provide connectivity with more frequent access points, while expressways prioritize speed, safety, and efficiency by limiting interruptions. Understanding these differences helps engineers, planners, and travelers make better decisions about road networks and transportation strategies. Joining us on Blueprint to Reality. If you enjoyed this breakdown, don't forget to like, subscribe, and stay tuned for more insights into civil engineering and infrastructure design. See you in the next video. The role of road design. Welcome to Blueprint to Reality, the engineering principles shaping our modern infrastructure to life. If you've ever wondered how roads withstand heavy rains and floods, today's video is for you. Let's dive into the essential role of drainage in road design. Why drainage matters in road design. Water is one of the most destructive forces. Without roads are exposed to surface water, leading to hydroplaning and increased accident risk. Structural damage. Water can weaken the subgrade, cracks and deformation. Erosion and environmental impact. Poor drainage can lead to soil erosion and damage to nearby ecosystems. Drainage systems are designed to manage these risks by effectively channeling water away from the road structure. Components of a road drainage system. 1. Surface drainage. Role. Removes water from the road surface. Features. Cambered roads. Ensure water flows channels. 2. Subsurface drainage. Role. Prevents water from seeping into the road's foundation. Features. Includes drain pipes and permeable layers to divert water away from the subgrade. 3. Side ditches and channels. Role. Collects water from the road and directs it to natural or artificial outlets. Features. These ditches are designed with adequate slopes to prevent stagnation. 4. Culverts and stormwater drains. Role. Allows water to flow beneath the road or to cross over natural barriers. Features. These are essential in areas with streams or heavy rainfall. 5. Catch basins and inlets. Role. Collect and funnel water into drainage systems. Features. Typically found in urban settings to manage surface runoff. Principles for effective drainage. Slope design. Roads are built with a crown or a cross slope to guide water off the surface. 2. Material selection. Permeable materials are often used to reduce water infiltration into the subgrade. 3. Capacity planning. Drainage systems are designed to handle peak water flow during storms. 4. Maintenance access. Engineers incorporate access points for cleaning and maintaining the drainage infrastructure. Challenges in road drainage design. Climate variability. Intense storms or changing rainfall patterns can overwhelm systems. Urban constraints. Limited space in cities can make drainage design more complex. Erosion control. Ensuring water doesn't damage surrounding areas is a constant challenge. Innovations in road drainage. 1. Permeable pavements. These surfaces allow water to seep through, reducing runoff and replenishing groundwater. 2. Smart drainage systems. Sensors and IoT technology monitor water levels and blockages, enabling real-time adjustments. 3. Eco-friendly solutions. Bioswales and rain gardens are being used to manage runoff while enhancing urban aesthetics. Life example. A great example of effective drainage design is the Rhodes in the Netherlands. Known for its low-lying geography and heavy rainfall, the country uses advanced drainage systems, including pumping stations and underground reservoirs, to protect its roads and infrastructure. Conclusion. Drainage is a silent hero in road design, protecting our roads from water damage, ensuring safety, and preserving the environment. Without proper drainage systems, even the best constructed roads would fail under the forces of nature. Thank you for watching Blueprint to Reality. If you found this deep dive into road drainage enlightening, don't forget to like, share, and subscribe. Hit the notification bell for more insights into the world of engineering. Until next time, stay curious about the structures that keep our world moving. The role of rollers in road construction. Welcome to Blueprint to Reality, where we uncover the science and art behind civil engineering and infrastructure projects. In this episode, we're focusing on a crucial machine in road construction, the roller. These machines might seem simple, but they play a vital role in creating strong, durable roads. Don't forget to like, share, and subscribe for more fascinating insights into engineering marvels. Introduction to rollers in road construction. When we think of road construction, we imagine asphalt layers and paving machines. However, none of these would last without proper compaction, and that's where rollers come in. Rollers are essential for compacting soil, aggregate, and asphalt to create a stable and long-lasting road. Without their contribution, roads would fail under the weight of traffic, leading to cracks, potholes, and structural issues. Let's dive into the types of rollers and how they're used in road construction. 1. The purpose of rollers in road construction. The primary role of rollers is compaction, reducing air gaps in soil, aggregate, or asphalt to increase their density. Proper compaction ensures the road can handle heavy loads without settling or cracking. Rollers also enhance the smoothness of the road's surface, creating an even foundation for paving layers. By improving stability and load-bearing capacity, rollers directly contribute to the road's durability. 2. Types of rollers and their functions. Rollers come in different types, each designed for specific tasks. Smooth-wheeled rollers. These are commonly used for compacting asphalt layers. Their steel drums apply even pressure, creating a smooth surface. Pneumatic rollers, featuring rubber tires. These rollers are ideal for compacting granular materials and asphalt, as they provide better coverage and flexibility. Sheep's foot rollers, with lugs or feet on their drums. These are used for compacting clay and silt to soils. Their design ensures deep compaction, making them perfect for subgrade layers. Vibratory rollers. These use vibrations to achieve better compaction, especially for coarse-grained soils and aggregates. Vibratory rollers are widely used in modern road construction for their efficiency. 3. Preparing the site for compaction. Before rollers, the site must be prepared. It involves leveling the ground and spreading materials like soil, aggregate, or asphalt in uniform layers. The thickness of these layers is carefully controlled, as improper layering can lead to uneven compaction. Site preparation ensures the roller's efforts are efficient and effective. 4. The process of compaction. Compaction is carried out in multiple passes, starting from the edges and working toward the center. Rollers apply both static pressure and dynamic forces like vibrations to eliminate air pockets and achieve uniform density. The number of passes depends on factors like soil type, layer thickness, and the weight of the roller. Engineers monitor the process using density tests to ensure the required compaction level is achieved. 5. Challenges in using rollers. Operating rollers comes with challenges. For example, overcompaction can damage materials, while compaction leads to instability. Different soil types require specific rollers and techniques, and weather conditions like rain or extreme heat can affect the compaction process. Skilled operators and precise planning are essential to overcome these challenges. Innovations in roller technology. Modern rollers are equipped like GPS systems, compaction meters, and automated controls help operators monitor progress in real time. Vibratory rollers with adjustable frequencies and amplitudes offer greater versatility, making it easier to handle diverse materials and conditions. 7. The impact of proper compaction on road quality. Properly compacted layers create a strong foundation, reducing the risk of road failures like cracks and settlements. This translates to longer-lasting roads, fewer maintenance costs, and safer driving conditions. Rollers, therefore, play a pivotal role in the overall success of road construction projects. Conclusion. The unsung heroes of road construction. While they may not grab the spotlight, rollers are indispensable in road construction. Their ability to compact materials efficiently ensures roads are strong, stable, and durable, standing the test of time and traffic. Thank you for joining this exploration of the role of rollers in road construction. If you found this video to blueprint to reality for more captivating engineering content. Until next time, keep rolling toward engineering. The role of toll booths in highway maintenance. Welcome to Blueprint to Reality, where we explore the modern infrastructure. Today, we're diving into an essential component of highway systems, toll booths. These structures play a crucial role in funding, maintaining, and improving highways. But, and why are they necessary? Let's break it down. What are toll booths? Toll booths are along highways where drivers pay fee for a particular road. The revenue collected helps fund road maintenance, expansion, and operations. These booths are commonly found on toll roads, bridges, and tunnels, ensuring that those who benefit from these routes contribute to their upkeep. Toll collection has evolved over the years. While early systems relied on manual payments, today's highways use automated and electronic toll collection (EDC) systems, reducing delays and improving efficiency. Why are toll booths necessary? Highways require constant maintenance to repair damage, upgrade infrastructure, and ensure safety. Unlike tax-funded roads, toll highways follow a user-pay system that would contribute to its maintenance. This approach has several benefits. Steady revenue stream. Toll booths generate consistent income for road repairs and improvements, reducing reliance on government funding. Reduced public tax burden. Instead of raising taxes for all citizens, use the highway to pay for its upkeep. Better road quality. Since toll revenue is directly invested into maintenance, these roads tend to be smoother, safer, and better managed. Encourages many toll roads are by private companies, reducing the financial burden on governments. Types of toll booths and collection systems. Payment methods based on the level of automation and efficiency. The main types include 1. Manual toll booths. Traditional booths where drivers stop to pay using cash or card. While simple, these booths can cause congestion, especially during peak hours. 2. Electronic toll collection (EDC) systems. Use RFID tags, transponders, or license plate recognition to automatically deduct tolls from prepaid accounts. Examples include EasyPass US, FASTag India, and AutoPass Norway. 3. Open road tolling (ORT). Completely eliminates physical toll booths, allowing vehicles to be charged electronically at full speed. These systems use sensors and cameras to identify vehicles, reducing delays. For distance-based tolling, charges vehicles based on the distance traveled rather than a fixed fee. This system is used in Germany and Austria for truck tolling. Each system is designed to balance efficiency, revenue collection, and traffic inconvenience for drivers. Impact of toll booths on highway maintenance. Toll booths play a direct role in keeping highways in top conditions, fixing potholes, cracks, and surface wear to maintain smooth driving conditions. Bridge and tunnel maintenance, ensuring structural integrity, repainting, and preventing corrosion. Traffic management systems, installing and maintaining signs, barriers, and road markings to enhance safety. Snow. In regions with harsh weather, toll revenue funds plowing, de-icing, and debris clearance. Highway expansion projects. Adding lanes, building interchanges, and upgrading infrastructure to reduce congestion. By funding these improvements, improvements. Toll booths help prolong the lifespan of highways, making them safer and more reliable. Challenges and criticisms of toll booths. Despite their benefits, toll booths face several challenges and criticisms. Traffic congestion. Traditional toll booths can create bottlenecks, especially in high-traffic areas. This is transitioning to electronic tolling. Cost to drivers. Some commuters find toll, especially on long routes or roads with frequent toll points. Environmental impact. Stopping and idling at toll booths increases fuel consumption and emissions, contributing to air pollution. Equity issues. Toll roads may disproportionately impact lower-income drivers who rely on highways daily commutes. To address these concerns, many regions are adopting cashless tolling and public-private partnerships to improve efficiency and accessibility. Examples of successful toll highway systems. Several countries have effectively used toll revenue to maintain high-quality highways. Some notable examples include Japan's expressways, operated by private companies. These toll-funded roads are among the world's best maintained. France's autoroutes, managed by private firms. These highways offer well-maintained roads, rest areas, and efficient toll collection. United States turnpikes, roads like the Florida Turnpike and Pennsylvania Turnpike rely on toll revenue for continuous upgrades. China's national expressways, funded largely through tolls. These highways have enabled rapid economic growth and connectivity. These systems showcase how toll booths can fund and sustain world-class road networks when properly managed. Conclusion: toll booths are a vital component of highway infrastructure, ensuring that roads remain well-maintained, safe, and efficient. By generating dedicated revenue, they reduce reliance on public taxes, fund essential repairs, and while challenges exist, innovations in electronic tolling and automated payment systems are making toll collection faster and more convenient. Thanks for tuning in to Blueprint to Reality. If you found this breakdown insightful, don't forget to like, subscribe, and stay with us for more deep dives into the world of engineering and infrastructure. See you in the next video. The Science of Shoulder Design in Highways. Welcome to Blueprint to Reality, the channel where we dive deep into the wonders of civil and structural engineering, breaking down the concepts that shape the world around us. If you're passionate about understanding the science behind the structures we rely on every day, you're in the right place. What are highway shoulders? Highway shoulder lanes located outside the driving lanes. They serve from providing space for emergency stops to acting as a structural support for the pavement. In essence, shoulders are the unsung heroes of road safety and functionality. But what makes their design so important? The answer lies in their ability to balance safety, usability, and structural integrity. The key functions of safety margin. Shoulders offer a safe area for vehicles that encounter mechanical issues or emergencies. This helps prevent collisions by keeping stationary vehicles out of traffic lanes. 2. Emergency access. Emergency vehicles like ambulances and shoulders to bypass congested traffic. 3. Structural support. Shoulders reduce stress on the edges of the pavement by providing lateral support, minimizing cracking and deformation over time. 4. Drainage facilitation. Shoulders help channel rainwater away from the main roadway, preventing water pooling and reducing skid hazards. Clearly, shoulders are more than just extra space. They are perfect shoulder. Design is influenced by several, including road type and safety requirements. Here's a breakdown of key. The standard width of a shoulder varies between 2.5 and meters. This provides enough space for most vehicles while maintaining the structural integrity of the pavement. 2. Surface type. Shoulders can be paved or unpaved. Paved shoulders are smoother, safer, and more higher cost. Shoulders made of gravel or compacted soil are more economical but require regular maintenance. Slope. A slight slope, typically 2 to 6%, is added to shoulders to aid water runoff and prevent erosion. For markings, bright white or reflective edge lines separate shoulders from the main road, improving visibility and guiding drivers during low light. Each of these elements ensures that the shoulder functions effectively under various conditions. Challenges despite their importance, shoulder design isn't without challenges. Factor terrain, budget constraints, and maintenance requirements often complicate the process. For instance, in mountainous areas, constructing wide, stable shoulders can be expensive and logistically difficult. Another challenge is maintaining unpaved shoulders, which can erode or develop potholes over time. Regular inspections and timely repairs are essential to keep shoulders functional and safe. Innovations in shoulder design. To overcome these challenges, engineers are turning to innovations like permeable shoulders. These allow water to seep through, reducing surface runoff and improving drainage. Recycle materials. Using recycled asphalt or concrete for shoulder construction reduces costs and environmental impact. Smart sensors. Sensors embedded in shoulders can detect vehicles in distress and alert authorities for faster assistance. These advancements are transforming shoulders into intelligent, sustainable components of modern highways. Conclusion. So, the next time you're driving on a highway and spot a shoulder, take a moment to appreciate the science behind its design. These unassuming strips of road are vital to safety and the long structural support to emergency actors. Do it all quietly and efficiently. That's the science of shoulder design in highways. you for watching. If you enjoyed this video, don't forget to like, share, and subscribe to Blueprint to Reality for more insights into the apps that keep our world moving. Traffic congestion, causes and solutions. Welcome to Blueprint channel for exploring the fascinating world of civil and traffic engineering. Today, we're tackling a topic that impacts millions of people every day: traffic congestion. Let's explore what causes this gridlock and the innovative solutions engineers are implementing to keep our roads flowing smoothly. Understanding traffic congestion. Traffic congestion occurs when the volume of vehicles on a road exceeds its capacity, leading to slower speeds, longer travel times, and increased frustration. While it might seem like an inevitable part of modern life, it's a problem influenced by various factors, including urban growth, vehicle density, and infrastructure limitations. Population growth and urbanization. Rapid population growth and urbanization are major contributors to traffic congestion. As more people move to cities, the demand for road space increases. Unfortunately, in many areas, infrastructure expansion hasn't kept pace with population growth, leading to clogged streets and highways during peak hours. Commuting patterns. The traditional workday creates predictable surges in traffic during morning and evening rush hours. These commuting patterns concentrate vehicle movement into specific time frames, overwhelming road networks and causing delays. Flexible work schedules and telecommuting are explored to spread out traffic volume. Insufficient public transportation. A lack of efficient public transportation options forces more people to rely on private vehicles, contributing to congestion. Cities with underdeveloped bus, train, or metro systems often experience higher levels of gridlock, as public transport can play a crucial role in reducing the number of cars on the road. Infrastructure challenges. Outdated or poorly planned infrastructure also exacerbates congestion. Narrow roads, inadequate intersections, and limited lanes are common bottlenecks. In some cases, construction projects or road maintenance further restrict capacity, compounding traffic delays. Traffic incidents. Accidents, breakdowns, and other incidents are unpredictable factors that can severely disrupt traffic flow. Even minor fender benders can lead to issues, particularly traffic. Promising solutions to tackle congestion. Smart traffic systems use real-time data from sensors and cameras to optimize traffic light timings and goals. Navigation apps like Google Maps help drivers avoid congested routes, reducing the overload on certain roads. Long-term infrastructure planning. Building new roads and expanding existing ones are traditional methods of addressing congestion. But these solutions alone are often insufficient. Modern urban planning incorporates mixed-use development, pedestrian-friendly designs, and improved public transit systems to create cities less reliant on cars. Promoting sustainable alternatives. Encouraging the use of sustainable alternatives, such as cycling, walking, and carpooling, can significantly reduce congestion. Many cities are investing in dedicated bike lanes, pedestrian pathways, and incentives for carpooling to shift travel behavior and ease road demand. Thanks for joining us on Blueprint to Reality as we explore the causes and solutions to traffic congestion. If you enjoyed this breakdown, hit like, subscribe, and tap the bell icon to stay informed about the world of engineering and infrastructure. Together, let's design better roads and build a smoother future. See you in the next video. Traffic signs, their design and importance. Welcome to Blueprint to Reality, the channel where we explore the fascinating world of engineering and infrastructure. Today, we'll dive into the design and importance of traffic signs, those silent yet critical guides that ensure order and safety on the roads. Let's explore how these symbols of structure keep our world moving. The role of traffic signs. Traffic signs are essential tools for regulating, warning, and guiding road users. Their primary purpose is to ensure road safety by conveying important information in a clear and concise manner. From indicating speed limits to warning about hazards, traffic signs create a predictable and orderly flow of vehicles and pedestrians. Without these visual cues, navigating the roads would become chaotic and dangerous, increasing the likelihood of accidents and confusion. Design principles of traffic signs. The design of traffic signs is rooted in simplicity and universality. Clear, bold typography ensures readability, while high contrast colors, such as red for warnings and green for guidance, enhance visibility. Shapes are also standardized. Triangles for warnings, circles for regulations, and rectangles for information, allowing drivers to quickly understand the type of message being conveyed. Reflective materials or illuminated designs are used to maintain visibility at night or in adverse weather conditions, ensuring safety around the clock. Color coding and its significance. Colors are a vital element in traffic sign design as they evoke specific responses and help communicate their message instantly. Red signals danger or prohibition, such as stop or no entry. Yellow is used for warnings like sharp turns or school zones, while blue often conveys information or guidance, such as directions or services. Green is typically reserved for directional signs, while white and black are used for regulatory purposes, such as speed limits. This universal color scheme ensures that drivers across the globe can interpret signs quickly and accurately. Types of traffic signs. Traffic signs are broadly categorized into regulatory, warning, and guide signs. Regulatory signs enforce rules, such as speed limit or yield. Warning signs alert drivers to potential hazards, like slippery roads or steep grades. Guide signs provide essential navigation information, such as directions, distances, or landmarks. Each type plays a unique role in maintaining road safety and efficiency, ensuring that drivers have the information they need to make informed decisions while traveling. The science behind placement. The placement of traffic signs is a meticulous process guided by engineering principles and road user behavior. Signs are positioned at locations where they can be easily seen and understood in time for drivers to act. For example, warning signs are placed before curves or intersections, giving drivers ample time to adjust their speed. Height, angle, and distance from the roadway are carefully calculated to ensure optimal visibility without obstructing other traffic elements. Proper placement is critical for maximizing the effectiveness of traffic signs. Traffic signs and modern technology. Advances in technology are revolutionizing the role of traffic signs. Digital signs and variable message boards can display real-time information about traffic conditions, weather, or emergencies. Integration with smart vehicles is also becoming common, where onboard systems can read and interpret traffic signs to assist drivers. These innovations aim to enhance road safety and efficiency by providing dynamic, context-aware information that adapts to changing conditions. Global standardization of traffic signs. The standardization of traffic signs worldwide has been instrumental in creating a universal driving language. Initiatives like the Vienna Convention on Road Signs and Signals have established a common set of symbols and rules, ensuring consistency across countries. This standardization is especially crucial for international travelers, enabling them to navigate unfamiliar roads safely and confidently. The importance of maintenance. Maintaining traffic signs is just as important as designing and placing them. Over time, signs can fade, become damaged, or be obscured by vegetation, reducing their effectiveness. Regular inspections and timely replacements are essential to ensure that signs remain visible and legible. Reflect coatings need to be checked for wear, and digital signs must be updated with accurate and relevant information. Proper maintenance ensures that traffic signs continue to fulfill their vital role in road safety. Thank you for joining us on this exploration of traffic signs and their critical role in road design and safety. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon to stay updated. updated on all things engineering and infrastructure. Together, let's build a better understanding of the systems that guide us every day. See you in the next video. What are controlled access highways? Welcome to Blueprint Reality, where we explore the engineering behind modern infrastructure. Today, we're diving into the concept of controlled access highways, what they are, how they function, and why they are essential and safe transportation. Controlled access highways are a critical part of modern road networks, enabling smooth traffic, reducing congestion, and enhancing safety. Let's break it down. Definition and purpose. A controlled access highway is a road designed with restricted entry and exit points to facilitate uninterrupted, high-speed travel. Unlike regular roads where vehicles can enter from driveways, intersections, or side streets, controlled access highways limit access to designated interchanges. This design minimizes delays, reduces accidents, and ensures a consistent traffic flow. Controlled access highways are commonly known by different names around the world. Expressways uncover causes like poor intersections,